Hello friends, and welcome back. In this video we'll be briefly talking about the vector product or cross product, which is one of the multiplication operations you can do on vectors. Let's draw two vectors just to illustrate the situation. This is vector A with a certain direction and a certain magnitude, and this is vector B. You already know that there's a type of operation we can do on these two vectors, which is called the dot product, which is very imaginatively denoted with a dot. And this gives us a number, c. And you may remember that this number is actually equal to the product of the magnitudes times the cos of the angle between the two vectors, okay? However, here we're doing cross product, which instead of a number, instead of a scalar, this operation returns itself a vector. So the cross or vector product A cross B gives us a vector C, which has the following properties. The magnitude of C is A times B times the sine of theta, okay? Theta is the angle between A and B, and the smaller of the two angles, so the one between 0 and 180 degrees. Because if you consider this other angle, which is 2 pi minus theta, then the sign would be the opposite. So all of this wouldn't be valid. So take the smaller of the two angles between the two vectors, and you'll be good to go. And then what about the direction? For this, you want to use the right hand rule, which is easier to explain if I have well, a live in person. I'm going to try my best to explain it in words, but you know, bear with me for a minute. So the right hand rule goes like this. Imagine that you're looking at the screen, and currently you have your right hand in front of you with, well, spoiler, with your thumb sticking out, pointing toward your nose, and you have your open palm across that is oriented like the vector A. So imagine that you sweep from A to B with your thumb stuck in the middle here in the pivot, right? So if you go from A to B with your right hand, then your thumb is in the direction of the vector C. You can probably imagine that if you try the same operation, but this is B and this is A, the way you can achieve it, where you swipe from A to B, is by your thumb, your right hand, the thumb of your right hand sort of pointing into the screen or into the page. Okay, so this is what we mean by a right hand rule. And a completely equivalent way to phrase this is if you take your right hand. I'm going to try to draw it now. We'll see what happens. Let me clean the page just a second. So if I take this and move it here, imagine that I have the two vectors again. Let me draw in different colors. So this would be A, and let's say that there's a B pointing this way. And you imagine to take your right hand with your index finger oriented as like A, and your middle finger and these are your ring finger and your pinky, then your thumb, which is, I mean, I'm not even too upset about this. This is pretty much as good as I can hope to achieve. Looks like a Mickey Mouse hand, but whatever. Yeah, the nail helps. Does it? I don't know. Then your thumb is sticking out of the page, and so just in the same technique as we described. All right, apologies to the visual artists out there. So please, I hope you remember to skip ahead next time you watch this video. But yeah, thank you for your patience. And this is the cross or vector product. Why cross? Because we denote it with a cross instead of a dot or an X. Why vector? Because it's an operation that returns a vector itself and not a scalar. Other notations that you may encounter here and there are, instead of a cross, a wedge. Where, I mean, formally there is such a thing as wedge product, which is related to the vector. It's a generalization of the vector product, but it's for a more sophisticated maths. I mean, the details of it. But this is another notation that you can find with a wedge. Okay, I will try to use an X consistently. But if sometimes I forget and I use a wedge, then apologies. But it means the same thing. All right, nice. Thank you so much for listening, and I'll see you soon.